Problem number 51. Figure shows two blocks connected by a cord of negligible mass that passes over a frictionless pulley also of negligible mass. The arrangement is known as Atwood's machine. One block has the mass m1 equal to 1.30 kilogram and the other mass has m2 which is equal to 2.80 kilogram. What are the magnitude of the block's acceleration and the tension in the cord? So in this question, we have to find the answer for A and B. So in part A, we are going to find the acceleration of the block, which is A value. And in the second part of the question, we are going to find what is the tension created in the cord, which is a T value, right? And before that, we have to take two information into our consideration. The mass of the string and the mass of the pulley are negligibly small when you compare with M1 and M2. That means we no need to take into our considerations regarding the mass of the string and the pulley mass. Only we have to frame the equation by M1 and M2. So if you want to find the answer for the acceleration and the tension, then we have to draw the free body diagram. So here, this is the system which is called as Atwood's machine. So we have to draw the force acting on the system. So let's we take the left hand side of the system. So here, the left hand side of the system, we connected the cord with M1. So when you connected, the tension will be created in this direction. And here you have the force due to gravity, which is a straight line. Okay. So M1 multiplied by G. Likewise, if you see the right hand side of the diagram, we have M2. So by that, the tension will be created in this direction. And then the force due to gravity on M2 is M2G. Now, the most important thing, we have to see in the left hand side of the diagram, your tension is greater than M1G. And in the right hand side, your M2G is greater than tension. Clear? So now what we have to do, we have to frame the equation with Newton's second law of motion, which is F is equal to ma. So now I am going to frame the equation for the left hand side. By that, we can easily get the answer for acceleration and the tension. As we told, in the left hand side, the tension is greater than m1g. By that, I can write the equation T minus m1g, which is equal to m1 multiplied by a. Why? We have to equate this term with the Newton's second law of motion. So let's we take this equation as 1. Likewise, we have to see the right hand side of the equation. What we studied, we said the m2 is greater than the tension. So by that, we have to frame the equation m2g minus tension, which is equal to m2 multiplied by a. So we have to take this equation as our second equation. Now what I am going to do, I am going to add two equations, 1 and 2, both the left hand side and the right hand side. So what I am going to do, I am going to add equation 1 and 2, both left hand side and the right hand side. What is in the left hand side? So let's we add the left hand side of this two equation. T minus m1g plus m2g minus t is equal to m1 multiplied by a plus m2 multiplied by a. So now here you can see the tension has the positive value. Here the tension is negative. So plus t and minus t get cancelled. And we can just take the g as a common term. So let's we take a g as a common term here. So what we will get? We will get minus m1 plus m2, which is equal to, we can take acceleration a as a common term. So therefore a equal to m1 plus m2. Now we have to simplify this equation, and after that we can substitute the value in this equation. So let's we rewrite this equation again. So I can write this as g multiplied by m2 minus m1, which is equal to a multiplied by m1 plus m2. Now we are going to find the answer for the acceleration. So I have to rearrange this in terms of acceleration. Therefore, the acceleration a equal to g multiplied by m2 minus m1 over m1 plus m2. Now I am going to substitute the value in this equation to get the answer for the acceleration. As we know, the g value takes the value of 9.8 meter per second square, and the m1 in the question they gave as 1.3 kilogram, and m2 takes the value of 2.8 kilogram, and g value is 9.8 meter per second square. Now I am going to substitute all these value in this equation. By that we can get the answer for the accelerations. Let's we substitute the value. So a equal to 9.8 multiplied by m2 2.8 minus m1 1.3 divided by m1 plus m2, which is 1.3 plus 2.8. So let's we see the answer for this. So here I have to substitute the value in my calculator. So let's we see what's the answer. 9.8 multiplied by 2.8 minus 1.3 divided by 1.3 plus 2.8. So I got the answer here as 3.585. So the acceleration value here is 3.585 meter per second square. So if you rounded this to 2 digit, we can write this number as 3.59 meter per second square. So this is the answer for our first question. Now we have to find the answer for the second question, which is what we are going to find. We have to find the value for the tension in the cord. So you have two equations, am I right? So we frame two equations. You can use any one of these equations to get the answer for tension. If you use the first equation, you can get the tension. If you use the second equation, you can also get the value for the tension. That means two equations. That means the tension created in the cord will be same on both left hand side and the right hand side, and also the acceleration between m1 and m2 also the same. So now what I'm going to do, I'm going to use the first equation. So let's see, or I can just show you for both equation. By that we can get the clear picture, right? So if you use any one of the equation, you can get the answer. So let's work out with the two equation. So I'm going to write both equation. So what is our first equation? Our first equation is t minus m multiplied by g, which is equal to m1, which is equal to m1 multiplied by a. What is our second equation? m2g minus t equal to m2a. So let's we go back to check the equation whether it is right. Mt minus m1g, right? So this one is m1g, which is equal to m1a. So let's we cross check the equation. St minus m1g, which is equal to m1a, and also the second, which that means right. So now what we have to do, we have to rearrange this equation in terms of tension. So first we can consider the left hand side. So t, which is equal to m1a, when you move this term to the right hand side, it will take the positive value plus m1 multiplied by g. So let's we take m1 as a common term. So inside the bracket we will get a plus g. And if you rearrange this equation of the right hand side in terms of tension, so I have to move this to the right hand side. By the time the tension will take the positive, then I have to move this term to the left hand side. By that it will take the negative value. So let's rearrange this equation. So m2g, I'm going to move this to this side. So by that it will take a negative minus m2 multiplied by a, and I'm going to move this negative tension to the right hand side. By that it will take the positive value. And here we have m2 as a common term, so we can take m2 as common. So m2 in the bracket, inside the bracket we have g minus a, which is equal to t. So now I am going to substitute the value. So better I can write this equation in terms of t. So by that it will be clear picture. So t equal to m2 multiplied by g minus a. So now we have all the values. m1 is already given in the question, which is m1 equal to 1.3 kilogram. And what's the value of the acceleration? In the previous, that means in the part A, we find the acceleration value is 3.59. So I have to write this value 3.59 meter per second square. And then g value we know, which is 9.8 meter per second square. So let's we substitute the value in the equation. So here t equal to M1 1.3 kilogram multiplied by 3.59 plus 9.8. So let's see what's the answer. 1.3 multiplied with the 3.59 plus 9.8. I got the answer here as 17.407. So I can write this in terms of two digits. So 17.41. So I got 17.407. So when I just rounded these to two digits, 17.41. And what's the unit for the tension? It's Newton. So let's we use the second equation. And by that you have to get the same answer. So now I'm going to substitute the value. So T equal to, what's the value of M2? In the question they gave the value of M2 as 2.8 kilogram, right? And then A value is 3.59, which we got in part A, and G value is 9.8. So let's substitute the value. So 2.8 multiplied by 9.8 minus 3.59. Let's see the answer. 2.8 multiply 9.8 minus 3.59. I got the answer as 17.38. So we can round this number to 17.438 we got. So if you round it, you can get 17.39, which is exactly closer. Am I right? So if you use the first or second equation, our answer will be the same. If you want to round this number to single digit, let's rounded this. T equal to 17.4 Newton. And if you rounded this number, T equal to 17.4 Newton. So the answer will be the same, right? So this is the answer for this question. Thank you.